Hello guys, this is Aayush Gupta. Today I bring you a second lecture in the MATLAB series after introduction. This lecture belongs to the some numerical techniques to solve the system linear equation. Today I will be covering two or three methods, namely Gauss-Seidel method, Gauss Jacobi method, and if time permits, then I will be covering Gauss elimination method. So first I will cover the theory, what are these methods, and then I will show you how to make a code in the MATLAB interface along with the example of all three methods with the general code and simple code. Now starts with the theoretical part. The first method is Gauss-Seidel method. Gauss-Seidel method. Okay. To explain the method, I will be using one example and solve it. What is the method through this example? Okay. Uh, the equation will be used is this equation 6x plus y plus z is equal to 105. This is said equation number 1. Second equation is 4x plus 8y plus 3z is equal to 155. This is equation number 2. And third is 5x plus 4y minus 10z is equal to 65, which is equation number 3. Okay. Now the first thing to do in Gauss-Seidel method is to you have to first guess the initial values of all three values x, y, and z. So I will use the initial values of x naught is equal to 0, y not equal to 0, and z not equal to 0. These are the initial guess for x, y, z in this equation. Second step is to we have to find all the variables x, y, and z in terms of other variables from the given equation. As x is found from the first equation, y is found from the second equation, and z is found from the third equation. Like this, x is equal to 1 divided by 6, 105 minus y minus z, and y is equal to 1 by 8, 155 minus 3z minus 4x, and similarly z is equal to minus 1 by 10, 65 minus 4y minus 5x. In Gauss-Seidel method, what we have done is we first use the initial guesses, then we will find the each variable from the given equations, as x is found from the first equation, y is found from the second equation, z is found from the third equation. Now to find the values, we have to use these initial guesses. For x, initial guess is we use initial guess for y and z, which is equal to 0, and from this initial guess we find x1 is equal to 105 by 6 equal to 17.5. Now to find y1, we will use this x to find the y1. This x, we will put this x here to find the y1, and the y1 coming up to be 155 minus 70 divided by 8, which is equal to 10.625. Then we will find z1. for find to get the value of z1, we will use the values of x1 and y1, and by using the value of x1 and y1, it is coming out to be 65 minus 4 into 10 4 into 10.625, which is 42.5, and minus 87.5, and the value is minus 6.5. Now at this time we know x1, y1 and z1, which are x1 is equal to 17.5, y1 is equal to 10.62.5, and z1 is equal to minus 6.5. Then we will find the error. Error is equal to x1 minus x0, which is mod of this, and if it's less than 10 to the power minus 4, then the value we get, let us consider that value is xn, yn and zn. That is our answer. That is how we solve the Gauss-Seidel method. Okay. Now if I have to tell how to code for this, we will make an algorithm for that. Then we will go to the MATLAB platform to how to code this. Okay, what is the method and how to do in the MATLAB. Now I will talk about the algorithm. The algorithm is same. You have the equation. The first thing you will do in the MATLAB is first you will take the initial guess. Initial guess. Then we will find all variables in terms of other variables from equation 1 to 1. Find all variables. Okay. Then after finding all variables, we will find error. Error is equal to absolute value of xn minus 1. Okay, and then we will compare that error from the tolerance value, which is 0.0001. If error is less than this, if error is not less than this, then we will go to this step. This step, if error is 10 to the power minus 4, then we will print those values. Print x, y and z. These are the answer to our question. Okay, this is the algorithm for that. Now we will go to the MATLAB interface and show you how to write a code for Gauss-Seidel method. Fine. Now go to the MATLAB interface. This is MATLAB interface. To write a Gauss-Seidel method in MATLAB interface, first we will go to the M file. In the introductory lecture, I have told you all the code will be made on the M file code. So how to go to the M file? Write edit in the command window. This is the command window, and when you write edit, this editor is pop up where we can write our code. The first thing is to do is save this M file, and I am saving with name Gauss-Seidel. Okay, first I will clear everything from the workspace and clear screen from the command window. So I will get the clean workspace and clean command window. So make it habit to write clear and CLC before the write the code. Now for what I am doing, I am writing a code. Let's make some comment. Comment is, this is the code for the Gauss-Seidel method. Okay. Now first I have to write the equation, that is the coefficient matrix and the constant term. I will define the coefficient matrix with the A part. What is the coefficient matrix? Let's go to the equation, and our equation is 6x plus y plus z is equal to 105, 4x plus 8y plus 3z. So from here the coefficient matrix which is coming out to be the A, which is equal to A is equal to 6, 1, 1, 4, 8, 3, 5, 4 and minus 10. This is the coefficient matrix, and y is 105, 155 and 65. Okay, first we will write these two values in the MATLAB. How to do it, I will tell you in just a few minutes. First use square bracket to use the array or matrix. So if I use without semicolon, then it means I am writing in a row. This is 611 correspond to first row. Then we use the semicolon, which will go to the second row. Now second row is 4, 8, 3, 4, 8 and 3. Now third row is 5, 4 and minus 10. Square bracket close. This complete our the coefficient matrix. Then second our column matrix, that is the constant matrix, which is 105, 155 and 65. This is the column vector, not a row vector, so I will use transpose of y. Okay, now what will we do, what to do from the algorithm part? Now we have to take a guess. Okay, I will take a guess of x is equal to zeros 3, 1. Zeros represents to 0 and represent 3 rows and 1 represent column. First argument represents the row and the second argument represents the column. So it means I have this 0, 0 and 0. Okay. Now I will assign this x initial value to the another variable. That's how I can use this another variable to find the error. Okay. Next what to do? Next thing is to do, we will find the find everywhere. We will use equations, and we will use that equation in the loop form. And loop will be closed when error is less than 10 to the power minus 4. Okay. Now we will use for k is equal to 1 to 100. This is for the loop sentence, and then we go for x 1 first row first column. It means I will use for x. Now we will use the equation of x, and x equation is written to be like this: y 1 comma 1 minus a capital A first row and second column multiplied by x second row first column y cos minus a first row third column multiplied by x third row first column. This is the equation for the x. Now I will copy and divided by a 1 comma 1. Okay. Now I will copy this and write it again here. I will copy this and write this again x21, and here this is y21 and a21. Here x11 minus a23 set x31 divided by a22. Okay. Again for the z, x31 y31 a31 third x11 a32 x21, and this is a33. Okay. Now we find error. Error is equal to x minus absolute value of x minus x naught, and we will give this x value into x naught. Here x naught will change, take the value of x again, and if error is less than 10 to the power minus 4, if error is less than this, then break AK, otherwise continue होता रहेगा, and at the end display the value of x. Here the code is complete. Let's run it. To run the code, use F5. Here we get one error. Error is CLEAR. CLEAR. Now run it again. So we have some error. Error is dimension of matrix being concatenated are not consistent. There is a problem. Matrix dimension there. What will be the wrong? Here this is the problem. I have to use semicolon instead of use colon. So now use semicolon there and save it. Run it again. Now we have the answer 15, 10 and 5. Here you can see the value of k is 10, that is mean it run 10 iteration here, and now we check it with our equation. We will put this values in the third equation. 15, 10 and 5, 5 into 15 plus 4 into 10 minus 10 into 5. 75 plus 40 minus 50, 75 minus 10 is equal to 65 equal to RHS. As proved, our values are correct. So this is the way we can make a code. Now I will make another code. That code is for the generalized cost and not only for this equation. Now make another M file, edit, this is the another file, and now we use clear CLC, and this is the general code for the Gauss-Seidel method. Save it with the name Gauss-Seidel underscore general. To make a general code, first we have to take the input values. So just we make it little bit look very fancy. Then I will use this command fprintf underscore. It does look very good at the end. That's why I'm using this. And other fprintf \n code for the general Gauss-Seidel method. And again and inverted comma close fprintf and again use this Ctrl C, Ctrl V, use little bit more. That's how it will under the, and we will take user input of the coefficient matrix and then the constant matrix. So for the coefficient matrix we have used the A variable. So take the input, this command is input, and we write enter the coefficient matrix of the equation Ax is equal to y, okay, or b. matrix or column, constant column of equation Ax is equal to B. Inverted comma close. Now we have A value, Y value. Then we will use the initial guess. X is equal to zeros. Length of A, LENGTH. Length of A, comma 1. How length? Why I have used length of A? Because I am making a general code and I didn't know it is a 3x3 matrix or 4x4 matrix or 5x5 matrix. I don't know. So for that purpose, I have used the length of A. What length of A does? Length of A will tell you the number of rows. Now I have the X. Now I will use put this value in the another variable next 0 to find the error, and then for the loop part I will use the for k is equal to 1 to 100, and after that I have to put the equation. Now I want every equation in the single loop. So for that purpose I will use one more loop. In this loop I use for p is equal to 1 to length of LENGTH, length of A, okay, and here x p comma 1 was p is 1, and here I am using for x vector. For x vector I will use y1. So vector comma y p comma 1 minus here is minus y, and the coefficient of y is 1, that is the A matrix first row second column. So we use A matrix. For first row we use P because we are in the first row, and we will use second column and the third column, both column. So P plus 1 up to LENGTH, length of A, okay, and multiplied by the value, it is the x, y for y p plus 1 second row to last row length of A, comma first column, okay. This is only for the but let we have three variables x, y and z. If we find z, then for z we need x and y, okay. This equation will not work for the z or will not work for the y, because for y the second term, this term is for the y, this term will work for the z, but how will we incorporate the x value for the y? So we need one more term, and that term will come out from this equation. P first row, because we are in the first row right now, because P is 1, and this P will go from the 1 to P minus 1. Because we are in the first row, so P minus 1 is 0, so term will not be this term will not be working for the x vector, which is correct, or which is correct. We don't want to run, because we are finding x from the first equation. Now for that, x is also 1 to P minus 1, and first column, and divided by a p comma p. This is the whole equation, I guess. Now and it find error is equal to absolute value of x minus x naught. Then after finding error, interchange the value of x naught to x, and find if error is less than 10 to the power minus 4, then break, otherwise end. And at last display the value of x, and we will run this code and find the answer. Now run. Okay, there is a mistake here. The mistake is I haven't used the backslash n command after this one. Now again run this code. Okay, you can see it is very good looking. It is now we have to put the coefficient matrix. Now put the coefficient matrix, we have to use the square bracket here, otherwise we will not write the whole matrix. So for square matrix, 6 1 1, enter 4 8 3, enter 5 4 minus 10, bracket close. Now y value, first square bracket, 105, enter 155, enter 65. Square bracket close, and then we have the correct answer 15.5, which will be found from the previous code also. So this is the way to write the general code for the Gauss-Seidel method. Now second method is the Gauss Jacobi method, and the difference between the Gauss Jacobi method and the Gauss-Seidel method is very small. Let me erase. So from this equation we will find x, from this equation we will find y, and from this equation we will find z. Okay, here in the Gauss Jacobi method we will do same, x, y and z we will find from equation 1, equation 2 and equation 3. The difference is that when we find the x from equation 1, we use y and z. Here y and z we use the initial value 0 0, x, y and z, and we find the x value, and this x value we use here in the equation, in the second equation, to find the y. But in the Gauss Jacobi method, we will not use this x value in this here. We will use the initial value here also. In here x and z initial value, here x and y initial value to find the z, not the value we will find in the above equation. This is the minor difference between the Gauss-Seidel and Gauss Jacobi method. And let's make a code for the Gauss Jacobi method. This is the simple difference. I think you will got you and we'll write a code. Let's go to the another M file, edit, okay. Make a habit to write clear CLC, and why we are using this M file. This is the general code for the Gauss-Jacobi method. Okay, here in this file, let's save this file first. Jacobi. Let's go general. In this code, I will show you another method, another thing, how to write a coefficient matrix and the constant matrix without keeping in mind to use these square bracket and there's all things. So first I will copy this thing from there to get good looking code. Okay. Now I will use, and I will take one more thing here. I have to input number of variables to make that go. Enter the number of variables or equation. Okay. For I is equal to 1 to n, and for j equal to 1 to n. Now I will use a coefficient matrix, input enter the one coefficient variable. Coefficient, enter the coefficient first. That's one. And end for the j vector, and we will write 5 vector also here. Input enter the constant. Okay, and this will complete your both coefficient matrix and the constant matrix. Now we will use the same command here. We will use everything for here, paste it, and the little bit difference is we will use x0 instead of x here only. X0 instead of x here, and we will run the command. Here it is asking for the 2 minus 4. Here are the numbers of variable or equation. Here we use the 3 equation, 3 by 3 matrix, and then it will also the coefficient. First is 6, another is 1, another is 1. Then constant matrix, either is 105. Then again equation is I think 8x. Let me 4x 8y 3z, and constant is 155. And then is next equation 5 4 minus 10, 5 4 minus 10 and 65. Here x is minus 6.5. Okay, there is a slight mistake in my code. I just forgot write I comma j here, and I comma 1 here. Sorry. Again do the same thing. 3 equation 6 1 1 105. Again 483 483 155, and 5 4 minus 10, 5 4 minus 10 65. No, this is the equation 15 10 5. Here keep in mind, here k values is 18. Here it takes 18 iteration to converge the roots, and in the Gauss-Seidel method we only have 10 iteration to converge the root. So from that point of view we can see that Gauss-Seidel method is faster than the Gauss-Jacobi method. Gauss-Jacobi method takes 18 iteration to give the right answer, whereas Gauss-Seidel only takes 10 iteration. Okay, I think this video is quite very large, so we will not cover the Gauss elimination method today, but in the next video I will cover the Gauss elimination method and some other techniques to solve the equation. Maybe in the next lecture I will cover other thing. Okay, that's it from my side.